Okay, let's continue. So we have discussed about the secondary wavelength concept based on Huygens principle. So basically here in the slit space here, we can have one secondary wavelength like this, or like this, third one, a fourth one, a fifth one, and a sixth one. So how many secondary wavelengths should there be in the middle between the edges of the slit? Do you know how many? Well, there are like a infinite of them, okay? So there's a lot of them, like thousands of them, because you can see that it contains infinite number of points, right? And each point there can be a secondary source. So now we need to study about diffraction, and diffraction basically is the result of superposition from many source, and we can just like do it pairs by pair. So to make it easier and can consistent, we can just like divide all the secondary wavelets into pairs, right? And to make it fair, we can just like pick two that can always have a distance between them is like half of the slit, right? So then you can see that between the edges of the slit that can be like on the pairs, right? And each of them always, then each of them will always, two of them always like distant from each other by half of the slit size, right? So if we can study the resultant pattern interference between these two sources, S1 and S2, then we can just like from there figure out the result from other pairs, right? Because they will be similar, because always between them the distance is always the same to be half of the slit, right? So let's say if we can observe on the screen, which is far away from the slit, a point P. P can either can be a dark point or can be either a bright point, but it's very easy to spot the first dark fringe, right? And then we can see that from the source S1 to P, this is the path travel, right? And like this is just like the V propagation from S1 to P. Then also we got another wave travel from S2 to P. So then at P, it will receive two signals from the source S1 and S2. And then when we add them together, we can see if at point P that will be oscillate according to which phase, right? So if we can see we can calculate the path difference, then we can know better at P what it should be, a bright fringe or a dark fringe, right? So then in the next video, we will learn how to determine this path difference. This is the path difference, right? Between S2 to P and S1 to P. That's the path difference here, more specifically in the last video. Okay?